Well, welcome again to the third weekly wrap-up. In this week, we looked at just continuing um, our learning experience in terms of just naming organic compounds. It's important to be able to talk technically about an organic compound and talk about it sensibly. We can't just point at sort of random structures and say that one. We need to be able to actually identify a particular molecule and be able to draw it out. So, just in terms of things we covered, the previous week we looked a bit at sort of how to name structures and take a structure and develop its or at least take a name and then develop its structure. What we learned new this week was we learned to identify primary to quaternary carbon atoms. All right, so if we have some random structure like this, then this carbon over there is the quaternary one because it's bonded to four. This is important, four other carbons. This one over here is tertiary because it's bonded to three other carbons. This one is primary because it's bonded to one, and this carbon there will be the secondary carbon because it's bonded to just two carbon atoms. Just be careful of that. What is not primary, secondary, tertiary, and quaternary is, I don't know, a structure like this. This carbon there, although it's bonded to two carbons, it's not secondary. All right. The reason being is that this is sp2 hybridized. Primary, secondary, tertiary are all to do with carbons that are sp3 hybridized. Okay, so that was just a bit of nomenclature that we learned. Then we learned about the alkenes and some naming with that. And the hard part was just the cis and trans aspects of that. And I'm just going to deal a bit with that now as well. And then we learned about the alkynes. And the alkynes, also the nomenclature revolving around that, very similar, but of course there's no cis and trans. And then we did the aromatic compounds. And so this is the benzene rings. All right, and we learned a little bit about that. Learned that we weren't going to do anything about the chemistry revolving around that, but we do need to know how to apply this in terms of our nomenclature and assimilating it from that point of view. So we're at the end of chapter 2 now, but let me just quickly go and just this little bit on the cis and trans aspect, because this is something that can be very confusing for people to draw. So we need to get to know this because later on we're going to have to draw our double bonds. All right, so as an example, this would be a trans double bond, and this would be a cis double bond. We need to be able to draw these different structures out and recognize them, because when we learn some more nomenclature in 2 weeks' time, we have to be able to do this easily, because otherwise that nomenclature is going to be very confusing to us. So cis and trans in some ways is a bit easy because it always applies to when we're looking at a double bond, it's two of the same thing on the same side. So if I draw a line, this is an imaginary wall through the double bond, we can see that over here we've got a methyl group, over here we've got a hydrogen. These two are not the same things, they're not on the same side, but the methyl group over there and the methyl group on this one over here are on opposite sides, and so this one is our trans, and likewise over here we can see the two methyls are on the same side, and so they're cis. Or we could have considered from the point that there are two hydrogens there, two hydrogens on the same, and they're on the same side over there, and it's also cis. So do go and study this. This is critical that you can recognize this quickly in a molecule. For a lot of people, it's going to be very intuitive. You're going to see that very quickly. But for others, it means just looking at it carefully and trying to make sense of it. And I guarantee you, once you do that, the penny will drop and you'll figure that out. All right, so let's just do an example of using some nomenclature. And it's a long name. Let's not get scared with this, but here it is. What I want you to do, because this is a practice example, is I want you to write this down and I want you to attempt to answer it. It looks very complicated. In fact, it's such a long name, I've had to kind of go over 2 lines. I didn't have space to fit it over there. But I want you to just try this. You'll see it is not hard to do. Just break it down into its components, give it a try, and then pause the video and then restart again once you've attempted and see if you got it right and where you are. If you can do something like this, you're well on your way in terms of your nomenclature. All right. So the answer, as we're dealing with anything like this, we want to isolate our parent, and we very quickly see that our parent, hopefully we quickly see this, is this part. It's the cycloheptadiene. This is our parent. It's a heptadiene, which means it's got double bonds in it, but it's a cycloheptadiene, and the hept part means that we've got 7 carbon atoms. So it's a cyclic structure with 7 carbon atoms. So we draw that. Always a little bit more tricky than a 6-membered ring, but this should be it. 1, 2, 3, 4, 5, 6, 7. And we'll just number these carbons because that's going to help us put all our substituents on. All right, so when you're drawing this out and you're working out, number these things. Afterwards, when you draw your structure out neatly as your answer, you can leave the numbers off or maybe erase them. All right, so I randomly assigned the numbers. They're just going round. In this case, clockwise. It could have been anti-clockwise. It doesn't really matter. So now we've dealt with the cyclohept part, but it's a 1,3 diene, which means that there's a double bond in position 1 and 2, and then on 3 and 4. So now we've dealt with all that. Everything else we can now deal with piecemeal. We've got a tertiary butyl group on position 7. So tertiary butyl group will look like that. All right, so we've done that. 5 ethyl group, so we've got an ethyl group over there. So we've dealt with that. Isopropyl group in position 3. Isopropyl group dealt with. Methyl group in position 1. Methyl group. And then finally a phenyl group, all right, which is a benzene ring, and that's a 6-membered ring. Right, the aromatic ring, and it looks like that. All right, so now that I've drawn this out, you can see it's not perfect. If you're to write this, if you're to hand this in as an answer, that would be absolutely fine. You get your full marks for it. If you really want to be sort of neat about it, because you just were doing this on the rough, try and keep all your bonds the same length. You see this 7-membered ring is sort of too big. The bond lengths between it are a little bit too big and compared to the other. But that's just about making it a bit neater. It really isn't about anything else. Okay, so we can do that. The last thing that we need to do is just, I just want to go back to this cis and trans story and just try again. If we have a cis 2 ethyl hex 4E. Okay, I'm just making this up on the spur of the moment, and I'm doing this for a very good reason, because I'm going to show you that actually this name is completely rubbish. But we can still get a structure that we can do from this, hopefully. Let's see where I go with this. Okay, so it's a hexene, so 6 carbons. 1, 2, 3, 4, 5, 6. Again, number 2, 3, 4, 5, 6. That's the hex part. 4, double bond over there. So that's that part. 2 ethyl. So we put the ethyl group on. Then we go off in that direction. Doesn't matter. We've got that. And now we've got the cis part. And so that's to do with the double bond. So for some of you, this is very quick. You see, oh, wait a second. That double bond is definitely trans because it's kind of going on the opposite sides. For others, we have to draw a line, just an imaginary line through the middle. And then we compare and we see that over here we have a hydrogen. Over there we've got a CH3. They're not the same things on the same side. Likewise over here we have a hydrogen and we've got this whole big group. and those two things are not the same thing on the same side. So in order to get this right, we have to take this methyl and we've got to put it there, and this hydrogen has to go there. It's as simple as that. We just have to switch them around. If we do that, let's redraw it so that we up, down, and then down, because I switched them around. And then we put our ethyl group back over there. And now what we see is by switching that round, we've got two hydrogens on the same side, all right, of the double bond. So that now is a cis double bond. So this, this structure over there is the correct structure for that name that I drew up, but that name I drew up was completely wrong. And the reason being is that any name must have the longest parent as the longest chain as its parent, and actually the longest chain is 1, 2, 3, 4, 5, 6, 7. So this should have actually been a hept ene, all right, and because it was 7, and we always give the double bond the lowest number, so this still would have been a 2 ene, and 1, 2, 3, 4, 5. There's a methyl group on that position over there. So this would have been a 5-methyl, all right, one word, heptuene. Okay, but what I wanted to show you with that is that actually even with a technically incorrect name, you would still get the technically correct structure. And that's all I wanted to show you. And that's why I emphasize that the most important thing is being able to take a name and to draw a structure from that. Okay, so next week we're going to be looking at functional groups, and please read ahead on that in terms of the class. We're going to continue drawing out structures, but now we're going to be incorporating the heteroatoms like oxygen, nitrogen, and sulfur, and in a lot of different combinations. We're going to be learning a lot of new names, and so you need to be alert and awake for this. Anyway, enjoy until next time. Cheers.